In today's lesson, we are going to kind of expand on yesterday's lesson, the power rule, and we're going to look at some other derivative rules. So the first one is the constant rule, which says if f of x is equal to a constant, then the derivative is 0. So let's explain that a little bit more. If we have y equals 12, 12 is a constant. Well, let's think about what the graph of that looks like. That's just a horizontal line. What is the slope of a horizontal line? It's 0. So that means the derivative of a constant is 0. Okay, the constant multiple rule says that if you're taking the derivative of a constant being multiplied by a function, what you can do is just bring the constant out in front times and then take the derivative of the function. So all that would be is if I have y equals 8 times x to the 4th, what you can do is bring the 8 out in front and then take the derivative of x to the 4th. So this would be 8 and then times 4x to the 3rd, which is 32x to the 3rd. And then the sum and difference rule, so now applying just like adding and subtracting. If I have the function y equals ax to the power of n plus bx to the power of m, basically all it's saying is that we're going to take the derivative of both of these. So in this case, the derivative is, it would be the constant a, and then bring down the exponent n, x to the power of n minus 1. So that's just us showing that I took the derivative of the first term, and now I've got b times, bring the exponent down m, x to the power of m minus 1. So that's just fancy math notation for saying you can take the derivative of the terms separately. For example, if I have y equals 3x to the 4th plus 8x to the 10th, the derivative is, so 3x to the 4th, bring down the 4 and multiply times 3, so 12x to the 1 less is 3. And then take the derivative of the second term, bring down the 10, multiply by the 8, so 80x to the 9th. So just kind of 3 properties of derivatives. Okay, here are some examples. So I've got f of x equals 3x squared minus 4x plus 3. To find the derivative, just take the derivative of each term. So this would be 6x and then minus 4, and then the derivative of a constant is 0, and I don't need to write plus 0, so 6x minus 4, and we're done. Y equals 6 times the square root of x plus e. So let's take the derivative of both of these. First, I'm going to rewrite this as y equals 6 times x to the power of 1/2 plus e. So now the derivative is, let's bring the 1/2 down, multiply by the 6, so half of 6 is 3, times x to the power of negative 1/2. And then what's the derivative of e? Well, e, that's just a constant, it's a number, and that is 0. So now I just have to convert this. That would be 3 over the square root of x. All right, couple more examples. This one, y equals 7 over x to the 4th plus 5 over square root of x. Okay, let's rewrite that. Y equals, that is 7x to the power of negative 4 plus 5, that is x to the power of negative 1/2. And now derivative. Okay, bring down, so negative 28 x to the power of negative 5. Okay, half of 5, so 5 halves. And then x to the power of, oh, that would be negative 5 halves. Minus 5 halves. And then x to the power of negative 3 over 2. Okay, so now let's convert that. I've got negative 28 over x to the 5th. And minus 5 over 2, and that is the square root of x to the 3rd. Okay, let's do one more example, and then we'll talk about a horizontal tangent line. So y equals cube root of x squared plus 8 times the 4th root of x to the 7th. Let's first rewrite it. So that is x to the power of 2/3 plus 8 times x to the power of 7/4. And now the derivative is 2/3 x to the power of negative 1/3 plus 8 times 7/4 times x to the power of 3/4. And then let's rewrite this. So 2 over 3 square root x. If I'm going to multiply here, that is 14. And that is times the 4th root of x to the 3rd. Oh, I just realized I made a mistake. That was supposed to be negative 1/3 up here. And then this would make that the cube root. And there you go. Okay, the last part, horizontal tangent line. So let's think about that. If I have a curve, horizontal tangent line, when is there a horizontal tangent line? Well, right here, horizontal tangent line. So what does that mean? What's the slope of a horizontal tangent line? Horizontal tangent line, the slope is 0. So that would be when the derivative has an x value that gives you the slope 0. So let's say I have this function here, f of x equals x to the 3rd over 3 minus 3x squared plus 9x minus 10. The question is, when does this function have a horizontal tangent line? What x value would create a horizontal tangent line? Well, what we're going to do is first take the derivative of f of x. Let's see, if I bring down the 3 and then divide by 3, it'll cancel, so I'm left with x squared. Bring down and multiply, minus 6x plus 9, and that crosses off. So a horizontal tangent line is when the derivative is 0. So we want to find the x value when the derivative is 0. All right, so we can factor. This would be x minus 3 times x minus 3. So when x is 3 of the original function, it will have a horizontal tangent line because it's when the derivative is 0. Okay, there is your full video looking at more derivative rules. Good luck with the lesson.